Hello everyone. Today I'm going to discuss about Cannizzaro reaction. It's shown by aldehydes which are not having any alpha hydrogen. Aldehydes with no alpha hydrogen undergo this type of reaction, Cannizzaro reaction. So aldehydes are 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 C double bond alpha carbon which is not having any hydrogen. So that's why there is no any alpha hydrogen in this compound. So this type of compounds undergo Cannizzaro reaction in presence of a base NaOH or KOH we can say. So it will get reduced. So here it will give R R C double bond OH plus R double bond COH and H. So here it is oxidized product and here it is reduced product. So if a compound which undergoes both oxidation or as well as reduction in the same reaction, this type of reaction is called disproportionation reaction. So here this reaction is disproportionation reaction we can say. And for example, we can see here the mechanism of this reaction. If you take benzaldehyde, 2 moles of benzaldehyde, it will undergo Cannizzaro reaction in presence of NaOH and it will give oxidized product COONA plus benzaldehyde, benzyl alcohol it will give. Okay, so mechanism for this reaction, if you take mechanism, here it is benzaldehyde, it is accepting one OH minus from NaOH, it will give, here it is CO minus and here it is H and here OH. Now another all benzaldehyde will come and attack on this, and while the bond is rearranged, then this hydrogen will go and attack on this carbon and this bond migrates to towards oxygen. So here we will get C double bond OH. Along with this it will give CO minus and H is there, another H is here. Now if you see the benzoate ion C double bond O minus and benzylate ion C H2O minus. Among these two, which one is more stable? The stable oxalate ion is more stable here because here there is a resonance mechanism is present here, but here it is not possible. So this one is more stable benzylate ion. So that's why the hydrogen from this benzoic acid is shifts from hydronium ion, H plus ion shifts from this carboxylic acid to this benzylate ion. So here we will get benzoate ion and benzyl alcohol. So these two are the products and this is the mechanism for this Cannizzaro reaction. Now if you take two different types of moles, different types of compounds, if substrate if you take, this is cross Cannizzaro reaction we can say. So here it is HCHO. This is formaldehyde and this one is benzaldehyde. Among these two, which one can undergo oxidation and which one can undergo reduction. So based on the nucleophilic addition reaction, fastest nucleophilic addition reaction takes place at which carbon, whether it is a benzaldehyde or formaldehyde, at which carbon nucleophilic addition reaction is very fast. So alkyl alkyl are aldehydes. So aliphatic aldehyde we can say is a aliphatic aldehyde is highly reactive towards nucleophilic addition reaction, and benzaldehyde is less reactive because this electrophilicity of this carbon is less due to the resonance present in this phenyl ring. So that's why OH minus ion will go and attack on this carbon, which is aldehyde, formaldehyde carbon. So we will get here H double bond O, OH. And on the other hand, another benzaldehyde will accept. So here another H is there, and here it is O minus, O minus. So when it is rearranged to as double bond, then it will go and attack on this carbon. So you will get like this. So here it is H, C double bond O, OH we got, and here it is C, O minus H2. And now the same as we said, benzylate ion is less stable when compared with carboxylate ion. So that's why this hydronium ion will shift to this carbon. And now we will get benzyl alcohol CH2OH and HCOOH. COO minus. So formate ion it is produced. And if there is any electron withdrawing group or electron donating groups are present on the phenyl ring, then what happens to the reaction? So if there is a electron withdrawing group is present, then nucleophilicity of this reaction, nucleophilic addition reactions on this carbon or electrophilicity of this carbon increases. So oxidation takes place here. If it is a normal benzaldehyde, it is electron withdrawing group like NO2 we can take here. Then in presence of OH minus, it will give COO minus NO2 here and CH2OH here, which is reduced product. This is oxidized product and reduced product. When there is an electron withdrawing group is present, then oxidized product is produced towards the electron withdrawing group is present on which compound, and our reduced product is produced where there is no any electron withdrawing group. If there is an electron donating group is present on this carbon, then what happens? If there is an electron donating group is present on this benzene ring, then the reduction takes place at this compound. So reduction is compound. So nucleophilicity here, the electropositivity decreases because of plus I effect here. So that's why it will be less reactive towards nucleophilic reaction, addition reaction. So it is more reactive. So that's why oxidation takes place at this compound. So we will get benzoate ion, and here it will be CH3 CH2 OH we will get here. Okay, so this is another type of reaction. If there is deuterium is present, HOH, and so here in this compound, if there is deuterium is present, then what happens? So 2 moles of this deuterium we are taking here formaldehyde. In presence of OH minus, it will go and attack on this one, and it will go here, and D C the O minus and O HDs and HDs. Now another formaldehyde with D group will come here and it will be rearranged and this hydrogen will go and attack on this one. It will be like this. Now D C double bond O OH here it is produced and H the O minus D is produced. Now this hydrogen is shifted to this oxygen and then we will get D C double bond O minus and here it is H D and here it is OH, another H is present here. Okay, so here this is a compound that is produced when deuterium is present. So deuterium comes to deuterium is not transferred here, only hydrogen is shifted, not this hydrogen. So here there is a hydrogen here and deuterium is here. Among these two, which can transfer here because hydrogen bond is weak bond. So this one is weak bond when compared with the CD bond. So that's why this hydrogen breaks easily and it will transfer to this carbon. So now if O is taken as OD minus, then what happens? So H C double bond O H 2 moles here and here we will get C O minus H and OD here and here another mole of formaldehyde we are taking. Now this hydrogen shifts to here and we will get C H C double bond O ODTs and CH2 O minus and this deuterium shifts from this oxygen to here and we will get C, I'm sorry, it is H only, not C is not there here and this will be H C double bond O minus and CH3, here it will be CH2 CH3 right? Yes, CH3 OH it is. Okay, OH not H, it is D. So like this, different compounds shows different types of compounds it will produce products. So this is about Cannizzaro reaction, which is a disproportionation reaction. The compound which undergoes reduction is highly electropositive carbon, highly reactive compound towards nucleophilic addition reaction, and reduction compound is less reactive towards nucleophilic addition reaction will undergo reduction. So this is about Cannizzaro reaction. Thank you.